Electrician Live with your host, Paul Abernathy and Jay Grundberg.
What up, everybody? Welcome to another episode of Electrician Live. My name is Paul Abernathy, one of your hosts here for Electrician Live. And with me, as always, my co-host, cohort in crime, all the way from the great state of Colorado, where the Dragon Man lives, himself, Mr. Jay Grundberg.
Buddy. Happy Thursday night to you all out there, and I'm just glad to be back. As much as you talk about the Dragon Man, you would think that you have some type of affiliation with him. So I'm just, what is he to you? What is this guy, the Dragon Man, to you?
I don't need these headphones, I don't think. The Dragon Man, who is he to me? He's nothing.
You talk to him about him like he's some big shot.
Dude, you gotta watch yourself. So the Dragon Man is if nobody's ever gone and looked at it, the Dragon Man is located out in. Hold on, I gotta change something here, Jay, because I screwed something up. I gotta make sure I change something because I got way too much stuff going on. Dragon Man, he's out. Out in what is it? Colorado Springs.
Yep.
And he has this big old place out there where you can, shoot automatic rifles and everything. If you go to YouTube and look up Dragon Man, you just Dragon Man. That's what you type into YouTube and you'll find this guy. And he's just amazing dude.
That's cool, man. I'm already seeing Demetrio. Big shout out for the donation, man. We really do appreciate that. And right behind him, Aaron, of course, my brother. Big donation. Thank you guys for the donations already. So Colorado Springs is south of where I stay. A little story about the Springs. That's where when I came to Colorado roughly 20 years ago ish. That's where I stayed at, was in the Colorado Springs area. That's where I started my electrical career field at. That's where my son Xavier was born. And then we ended up migrating up north to Denver. So that's where I'm at now. So I'd probably say I'm about an hour, probably an hour and 20 minutes away from the Dragon Man.
Okay.
So
for a second,
if you ever come down here, we'll make sure we go see him and go say what's up to him.
Yeah, I'm noticing that I'm fixing stuff as I'm working on the stream because I have issues already for the stream tonight.
Michael Stanley, what's up, man? Thank you for joining the show. Demetrio, thank you for joining. Mex Amer, thank you. Ketsua, thank you. Woo woo. Spark It Up. Yeah, you might be from Colorado too if your name's Spark It Up. I don't know where you're from, but you might be my neighbor. Nolan, what's happening, man? Thanks for joining us.
Elwood's in the house.
Thank you for joining us. Elwood in the house. Aaron, my brother, you didn't make it last week. Hope you like the new additions.
Yeah. So what we say is, how are things in Colorado?
Things are going good, man. You can really tell that the fall's here. The mornings are a lot chillier. It gets darker at night, so that transition's already coming along. Work-wise, man, we are just slammed to the gills. You think that during this holiday seasons with, Halloween, Thanksgiving, Christmas, New Year's, these packed holidays coming up, you think that people would start slowing down, right. But that's not the case, man. We are slammed. Yeah. So I'm out there every day, whether it's project managing with guys, running material, job walking. I mean, I just find myself wearing multiple hats throughout the day, and I'm not complaining because I'm very blessed to where I'm at. So very thankful, to be honest with you.
Yeah. Eventually, I'm going to make it out to Colorado, and we're going to have to jump up there to Colorado Springs. So I also remind again, Demetrio and Aaron, hang around towards the end of the show so you can spin the wheel of goodness, and we'll get you some goodies out to you. Okay, so we have that going on.
Yeah, man.
So I mean, Texas is good. Starting to cool down. That's good. Most people know I'm going to be off next week on vacation. Can't wait to finally, take a week off, go to the lake, and just do nothing. Probably, well, not going to do nothing.
Nice.
I might go fishing. So we're going to go fishing
most of the week.
We'll get the boat. We'll put it in the water. We'll probably go fishing for most of the week. We'll go fishing. That'll make the wife happy. Got to make the wife happy. Happy wife, happy life. It's just not it's not just a saying, people. It's a reality.
No, it's actually
yes,
true.
Very true. Happy wife, happy life.
Are you going to be posting photos of your vacation on the Sparky Hub?
I don't know that electricians want to see my vacation, but if I catch a big old fish, daggone well, I'm going to be posting that.
There you go. There you go.
But it'll be good weather. Should be good weather. Should be kind of cool. Start be cooling down. It gets down in the 60s, 70s at night now, which is great. That's the way I wish it would be. I wish it would be 70s all year round, but
I know it.
But that's the best we can. That's the best we can go for. So anyway, all right. So Jay, what's our topic tonight? We want to get into our topic. We're going to talk transformers, right?
Yeah, we're going to talk transformers. We're going to get into the grounding and bonding course that you can find at Electrical Code Academy. Okay. It's our course that it's tailored to the grounding and bonding, and as if, unlike you, Paul, because you are on that panel, us electrician side, we don't always understand grounding and bonding. So we're really thankful to be a part of tonight's show, and I'm excited to learn something. Yeah, so I'm gonna kind of be a co-host / learner.
Yeah, well, grounding and bonding, it's probably one of those things that there's certain aspects of the NEC that people can make a career on, right? There's this guys that are locked into hazardous locations, and that's all they do, right? Class 1, Division 1 and 2, Class 2, Class 3. Yep. There's people that can make a career of that. And they do very well because that's a very niche type of niche or whatever, niche, whatever it's called. And then there's, of course, there's swimming pools, spas, and hot tubs. And there's people that 680 to just make a career. And of course, there's people that make a career in 690 for PVs and things like that. I mean, that's all they do. And then, of course, there's just guys that are really in the grounding and bonding. And of course, I was blessed enough to be on Code Making Panel 5, still on it. We did wrap up today. Our group, task group, we did wrap up the 2023s, at least our stuff for the official meeting that we have at the end of this month, or the end of October. So hopefully we'll be getting that knocked out of the way so that we can get all that taken care of. So again, yeah, I think that I've noticed in my videos lately that my voice over the mic is much deeper than it actually is. So that's probably enhanced by the microphone, but I'm too lazy to change it. So this makes me sound more manly. So I'll just go with that.
There you go.
Yeah. If not, okay. Yeah, I look like I got a little jaundice tonight. So I'm not going to change that either. I'm going to be lazy tonight with that stuff. Yeah, we're going to talk grounding and bonding, and we're going to be looking at, and I on this episode of Electrician Live, since we really have an hour, I really want to focus on what I find the core aspects of transformers, and that is understanding system bonding jumpers, supply side bonding jumpers, sizing system bonding jumper when it's not already provided by the manufacturer. But the good news is, along this journey, we're going to also learn, again, sizing main bonding jumpers, which, again, not part of a separately derived system. That would be like in your main panel. But since it utilizes the same areas of the code, right, it's going to, at least you're not wearing, Rockies or something. But so or I don't know, was that the Rockies, or was that?
No, that was my Orlando
Okay,
Magic
that's
hat.
okay, I guess. Whatever, but as long as it's not
Yeah, it's
Seahawks
not
or
bad.
whatever. So we're going to cover that today. We're going to look at that, but we're going to have a unique look into the grounding and bonding course, and look at the aspects of it to kind of show you what it shows you and the depth of a grounding and bonding course. And probably everybody needs to have a good understanding of grounding and bonding. So tonight's episode is transformers. So we're going to be dealing into that. Okay. And then of course we're going to have our code turd that we'll all look at together. I don't even think me and Jay had a chance to really go over the turd, but we'll look at it. And of course at the end we'll spin the wheel of goodness for what it looks like. What is it right now? It looks like for Demetrio and Aaron.
Have to,
so again, thank you all for those
Aaron,
donations.
I have to put those.
Last week's Electrician Live donators that spun the wheel, your stuff went out in the mail today. So if you're listening, you should get this stuff in the next couple days or so. So it did go out in the mail. So and Jay, the little one, tell them that Beanie Babies are on the way. Oh, there you go.
Oh, perfect.
All right. So let's go on and get to a lesson.
Yeah. So
go ahead. Go ahead.
Mex, before we get into it, Mex wants to know how's the workflow for commercial electricians in Colorado. It's booming, man. I'm not much on the commercial side myself. I'm probably 90% residential, if not a little more. But what I understand from my fellow buddies out there, it's just booming. I get hit up every other day from temp services trying to know if I know anybody that wants to go on a commercial job, if I want to go on a commercial job. And so there's a lack of electricians all the way around here in the state of Colorado. I can tell you that, whether it's residential, industrial, commercial, inspectors. I mean, for the lack of trade guys out here, there's just so much work. And that's why you find a lot of out-of-towners coming in, especially general contractors, right? You'll get general contractors from Michigan, from Texas, from California, from Florida. I mean, seriously, we probably have 30% of our general contractors here in the state of Colorado are from another state. And it's good, but it's also bad. You kind of want to keep it localized. You want to keep it in-house if you can, or in-state, but there's just too much work to keep up with at times, man. And again, no complaints on my end. I'm very fortunate. My guys, they've had 40 hours for the last, I don't know, 7 years that I've been in business. So we don't get slow, man. So.
Well, that's kind of like Texas, North Texas. It doesn't slow down. There's work all over the place. If you want it, it's here. Just come and get it. That type of thing.
Yeah.
So
come get it. That's right. Come get it.
If you want it, come and get it. All right, let's go on into the lesson.
Just don't get too buried into it, because you can overflow yourself now.
That's true. That is true. All right, so let's kind of get into the lesson. We're going to start this journey in 250.28. Now, I'll remind you first, and all students that understand, that learn the National Electrical Code understand there's systems that are required to be grounded. There are systems that are permitted to be grounded but not required. And then there's certain types of systems, and all these are in 250.20, 250.21, 250.22. And then there's systems that are not cannot be grounded. So you have systems that are required to be grounded. And a good example of a system that would be required to be grounded, a good example of that would be just like your residence, right? So one of the legs is 150 volts to ground, and that type of system there where there's a grounded system, that is a type of a system that is required to be grounded. It's not an option. So your residence that is not an option. That is a grounded system. Okay. And then of course we bring that neutral conductor down through the meter and straight down into the panel. That's a grounded system. But there are systems out there that are permitted to be grounded, but not required to be grounded. And a good example of that would be a corner grounded delta. You could have an open delta and you can have a corner grounded delta. So it's not required to be, but it's permitted to ground one of the legs. So there are different situations, and I encourage people to, in our program, the grounding and bonding program does cover all that, but I encourage you to truly try to understand a little bit about systems that are required to be grounded, some that are permitted to be grounded, and some that cannot be grounded. And all of those are covered in 250, 20, 21, and 22 of those. So I encourage you to check those out. We won't go into that today. We're going to stick with transformers. But I figured, Jay, while we're here, we're going to piggyback on main bonding jumpers as well to give a little bit of information on understanding that, okay?
Yeah. So important to know.
I mean, we take for granted, for example, many times we get a main panel, we've got a green screw. And a green screw or a bonding strap comes from the manufacturer. And we don't have to do anything. In fact, 90.7 of the National Electrical Code tells us that we don't have to reinspect that. It's part of the equipment. So that means that the manufacturer has sized that main bonding jumper, or they have already sized that system bonding jumper, and we don't have to do anything else. Okay? Right. So that is 90.7 just trying to tell the inspector, dude, you don't have to go in there and reinvent the wheel. It's already been evaluated. Now, there are situations where we have a situation where we're going to size our main bonding jumper, okay? You know what I'm saying? You're going to do an upgrade, and we're going to run the wire type or something like that, and we're going to have to size it. So it's not something that's inherent with the manufacturer. So kind of setting the stage for what we're talking about, because we want to go through it, because a lot of the stuff people take for granted, and we want to make sure that we kind of cover it. So while we're piggybacking transformers and system bonding jumpers and talking about separately derived systems, we want to make sure that we also let you know a twofer deal here. We're going to give you what you need to know about main bonding jumpers as well. So if you have your NEC or you happen to be following with your NEC, we're going to look at main bonding jumpers and system bonding jumpers first. So the requirement in 250.8, which is a dealing with main bonding jumpers and system bonding jumpers, as you see on the screen. Now, if you're over on the podcast, this is a great opportunity for you to come on over to the video stream and come over and watch it. And if you're listening to this podcast after this episode, it'll still be up there for you to go watch. I encourage you to go watch so you can get the flavor of what's on the screen. So here's what it says. The requirement for a grounded system, main bonding jumpers and system bonding jumpers are required to be installed as follows. So if you're thinking about it, in a lot of our program, we get into discussions. So there's not a lot of exam stuff here. These are discussions, and we kind of let you in the room in these discussions. For example, as it shows on the screen, it says main bonding jumpers are installed at the service equipment, and system bonding jumpers are installed at separately derived systems. And we have a figure we're going to look at here in a second. It says the definition of a main bonding jumper and a system bonding jumper, they're found in Article 100 because they're used in more than one article, so they end up being in Article 100. Now, in the introduction of our program, we kind of discussed what these do, but the main bonding jumper is a point in the system in the service equipment that allows you to connect the grounding electrode conductor to the grounded conductor, and of course, all equipment grounds to the grounded conductor. All this ties together in the main service equipment, not downstream, but right in the service equipment. So the same function of a main bonding jumper that you all are familiar with in a panel is the same function as a system bonding jumper in a separately derived system. So the thing about a separately derived system is if there's a fault condition downstream, then it has to allow that fault current to get back to the source. So if there's a system bonding jumper in the transformer and there's a fault and it comes back on the case or all metal, non-current carrying metal parts, and it gets back, it gets from there over to the XO, which gets back to the actual grounded conductor and allows for the function of an overcurrent protective device. Now, with the main bonding jumper in a panel, it's the same concept. The source is the utility, and that transformer just happens to be out on the pole somewhere or out on a pad. Same concept. But in there, that main bonding jumper allows the bridge between some type of condition, say where you have a ground fault or you have a fault where you have non-current carrying metal parts, and now it comes back to the main panel, goes from the bus through the main bonding jumper over to the grounded conductor, and allows that current to get back to the source, which is the transformer's side, secondary side. It allows for that overcurrent device to function properly. So it's critical in the safety system that you know what a main bonding jumper is, but when you're doing with the transformer, knowing that a transformer in all cases, except for auto transformers, and we'll talk about that, they are separately derived systems. Now, a couple things we're talking about, because I like to throw things out there. A generator may or may not be a separately derived system. Depends on whether you transfer, whether you switch the grounded conductor in the system or not. But that generates power. A transformer is still called a separately derived system, but it doesn't generate any power. All a transformer does is transforms power. It either raises it up or it changes it. Now, it doesn't raise it up and down like we think of in a buck or boost. That's an auto transformer. Okay, but that's not a transformer in the true sense of what we're talking about tonight. We're talking about primary, secondary transformer, where there is no intimate connection between the primary and the secondary. Now, the bonding and all is intimate, but the primary and the secondary are not. They're in close proximity, but they are not touching.
In that,
right? Okay,
they're not touching. That's crazy, because when I think of transformers, they're a lot of them are outside. They're the green boxes that you see, on the front of schools or the sides of maybe houses, and you always hear them humming. You always hear the That's what I think of when I see a transformer. It's not really, like you said, they're not really carrying. They're not really a separately derived system.
There's no perfect efficient transfer of power from primary to secondary. There's going to be some losses, and we refer to those things as hysteresis losses. Yes. There's a rapidly expanding and collapsing magnetic fields involved in it, and there's magnetic flux that transfers power, keeping it simple, from primary to secondary. And again, it's all based on turn ratios, to turn ratio, primary to secondary turns, and that all can affect what voltage we have on the primary versus what voltage we have on the secondary, whether we're 480 to 122.08 or something like that, or 480 to 122.40, depending on the transformer that we're purchasing, right? So when you look at this picture that I have on the screen, on the left side, you see a traditional panel. And here, the main bonding jumper is actually that jumper between the two buses. Now, it could be just that one bus on the left with the green screw in it. But in this case, they chose to break it up and have two multiple buses here, or terminal bars, than to have it all on one terminal bar, right? But since they are separated like that, the connection between those two buses in the main panel there, that is a main bonding jumper. And if it's of the wire type, you're going to have to size it. And it's going to be sized based on the conductors that are supplying that system, okay, for that. Now, you'll notice that it's leaving from there and it's hitting a transformer. You'll notice in that transformer graphic that primary winding on the left side is not in intimate contact with the primary winding on the right side. Okay, so they're in close proximity. However, you notice that the equipment grounding conductor that's being run on the left side, that green conductor that's going over to the frame, is in intimate contact with the secondary side, where you see the system bonding jumper located, because you see that system bonding jumper goes from the XO, the grounded terminal point, or the neutral point, over to the actual frame. Okay, and I'll try to bring the mouse up here, and I don't know, Jay, if anybody can see the mouse, but so this is your system bonding jumper here, and this intimate connection.
I'm not able to see anything.
You don't see it on the.
Oh yeah, no, I can. Go ahead. Yep, I can see it.
Trying to make sure you can see it on the screen. Yeah, you should be able to see it.
Nope, I can see it.
Okay, so in this case, this is your system bonding jumper right here. And it's connecting the XO on the derived conductors, which is off the secondary, over to the frame of the transformer, right? And then, of course, they're intimate together. But the primary to secondary windings are not. So that is a separately derived system. Okay? And so just giving people the lay of the land here. If your system bonding jumper is placed here at the source, right here at the transformer, then here, anything you would do downstream, you would separate. And of course, the grounded terminal bus is isolated, just like what you would do, folks, not keeping it, let's keep it simple. The same thing you would do on a main panel in your house, and you put a remote distribution panel in the basement. or as Jay would say, a subby, bruh. You're going to separate. Subby, bruh. You're going to separate. Okay? All right.
Yeah.
So that scenario, then you do here. Now, interesting enough here, you notice there's no neutral brought here because the neutral's derived from the secondary. It wasn't supplied to the primary because it wasn't necessary.
From the primary, sure.
But when this panel is derived here, then you're going to see the 4 conductors here, and you're going to see an isolated neutral bus, and you're going to see the, in this part going up to here is called a supply side bonding jumper. Okay. Now, why would we not call this an equipment grounding conductor, Jay? What do you think? Why?
Because you're still going from the transformer to the first main panel.
Right, but we know that equipment grounding conductors are based on what? They have to have an overcurrent device upstream, right? To size them.
Yep, on the branch circuit.
So in this case, there isn't really any. This is a secondary, and these are derived conductors. So this is a supply side bonding jumper. Okay. And these are all derived conductors. Okay.
Yep.
All right. So let me see if Yep.
Inside the remote distribution panels or sub panels that I put in the basements. Sometimes the inspector will actually require us to remove that main bonding jumper, or that green ground screw.
Well, I'm hoping you do remove it because you don't
way.
want it downstream unless you're using it for the grounded bus only, and it has no connection to the neutral.
Yeah. So we just pull those out, so that way none of the guys mistakenly try to put it in and then make a second bonding point.
Yep.
So.
Yep. All right. So let's kind of look at some material. Let's kind of real quickly have that. Yes. So separately derived systems are required to establish a grounding electrode. So I see a question Nolan has on the screen. So transformers do require to have their own grounding electrode system. Now, typically, if it's the transformers in the building, it will be connected to the building's system grounding electrode system. If it's an outside transformer that's originating outside, then it will have its own grounding electrode system. Okay. So again, inside the building, tied to the building's grounding electrode system. Outside of the building, its own grounding electrode system. Okay. All right. So let's look at some what makes this up and things that we should know in this process here. So the material of a system bonding jumper, because that's what we're talking about for transformers, but again, it is also going to apply to main bonding jumpers. It says main bonding jumpers and system bonding jumpers are required to be copper, aluminum, copper-clad aluminum, or other corrosion-resistant material. This is hotly debated what that actually means. Okay. But we know what copper is, we know what aluminum is, and we know what copper-clad aluminum is, okay? And you don't see a whole lot of the copper-clad aluminum, but you see an awful lot of copper and aluminum.
And aluminum, yeah. The copper-clad aluminum I've hardly seen out there.
Making a big sudden surge in the last because of costs, right? Because, copper's gotten quite expensive, so now that opens up the market for copper clad, which is a metallurgically bonded material. It's called a bimetal. It's not aluminum. It's not copper. It's a metallurgically bonded product with a certain amount of copper cladding over top of the aluminum. And it really, as we know, with 60 hertz and AC systems, that current really travels on the outer perimeter anyway. We don't have a lot of skin effect issues with 60 hertz applications. So it is adequate, but again, it's softer. And again, you better pay close attention to your terminations when you're working with the copper-clad aluminum. I'm just saying. Copper's a little more forgiving, if you will. Okay. Now, a main bonding jumper and a system bonding jumper can consist of a wire, a bus, a screw, like we might see in a panel, a green screw that has to be finished and invisible after installation in the green finish, or similar suitable conductor. So typically what we're going to see is either a wire, but in a lot of big switch gear, we may see a bus configuration that does this, where you have buses that interconnect together, that type of thing, that make up a main bonding jumper or even a system bonding jumper in a large transformer. Okay. But typically the wire is what we'd see, or we're going to see a screw, or we're going to see a similar suitable conductor, and that might be something that is supplied by the manufacturer. Okay. Like a strap that's properly sized or whatnot. Okay. So main bonding jumpers are typically furnished by the electrical equipment manufacturer and listed equipment intended for the use as service equipment. Why? Because main bonding jumpers are intended to be making connection to the non-current carrying enclosure with the grounded conductor. That's why you're connecting them all together. You don't do that downstream. You do that at the service. Now, there are some rare exceptions to that, where if you have like 250-142, I believe, where you might be dealing with existing ranges and dryer applications maybe. There's an allowance in 250.32b, I believe, for detached structure. If it was code permitted to be done a certain way up to a certain point, which I believe was prior to 2005 edition, then, you could use the neutral as the grounding as well to a separate building. That's why we had 3 conductors. Now it's got to be 4. But the building is still there. It's existing. You're still allowed to do that. That's 250-32b. But that, for the most part, you're not going to do that downstream. Okay. And so that's the general rule with that. Now, when that main bonding jumper or even a system bonding jumper, if that was supplied by the manufacturer, we're not reinventing the wheel, right? 90.7 is telling us that we can accept it without additional examination. It's fine. It's sized okay. Don't go crazy, Mr. Inspector. Okay. Now, when you have panel boards, you'll see that the UL 67, UL 891 for dead front switchboard, UL 231 for power outlets, UL 845 for motor control centers, and UL 98 enclosed switches. All of these, if they do have a main bonding jumper in there, it's going to, and it's included by the manufacturer. It's already okay. Don't try to reinvent the wheel. Inspectors don't have to be creative here. It's already been done by the manufacturer. Nobody knows the product better than the manufacturer. Okay.
Sure.
So here's an example of one of the, I say it's not a wire. It's not a bus bar. It would be one of those others. And so it looks like a wire, but then flattens out. So this is pretty common that you're going to see in a panel. And this is supplied by the manufacturer. It's perfectly fine. It's been evaluated to be able to handle the conditions that it will be placed under. It's considered sized properly. Don't have to do anything else with that. Okay. So it's an example. Larger equipment, larger than this is just a typical, maybe a 200 amp panel or something. A larger equipment that consists of one or more wires or bus bars. You might have a main bonding jumper that's an actual bus type, or you're going to see larger conductors. But I tell you, if you get equipment and you're the one, Jay, that has to size this, then you better learn how to size it. And we're going to go over how to size it. Otherwise, you just use what the manufacturer. And I'll also remind you that service equipment that is marked suitable only for use as service equipment can only be used as service equipment, because it means that the grounded conductor is connected, or the grounded conductor terminal is connected to the non-current carrying metal frame. And that can only be done as service. So you could not grab one of these, Jay, and use it as a sub panel, a remote distribution panel, if it was marked only suitable for use as service equipment. Okay. Because the neutral terminal is bonded to the enclosure at the factory. So that would be a violation under 250-24A5 to make that improper case to neutral downstream. Okay. And this is an example of one that might say suitable only for use as service equipment. And in this case is a dead front switchboard section. That is it. That is all it'll be used for. Okay. Now there is some allowances, Ken. So folks that aren't familiar with this, used to be the old white book that used to give you all the UL information. That's kind of gone now. They don't do the white book anymore. It's called the UL Product IQ database, and you go online and you get it, and it's all online, and it contains information, and it gives different phrases all through that for different equipment, using the phrase suitable only for use as service equipment appears. Okay. So interesting quote here. A section marked for use as service may also be used to provide a main control or disconnecting means for a separately derived system. True, if that separately derived system and everything has been set up for you to have the grounding electroconductor, the non-current carrying frame, and the grounding conductor to be bonded to it, because guess what? With a transformer, you have choices. You can put the system bonding jumper at the source, or you could do it at the first panel where you have your service disconnect or disconnecting means. Okay. So you have some options. Okay. All right. So construction of it. So when a main bonding jumper, or in our case, a system bonding jumper, is a screw only, then it must be identified with green. Y'all all heard that before. It has to be green finish, and of course visible with the screw installed. So after it's installed, it has to be able to see it, and that's what it's got to look like. So this is kind of a example of what it would look like right there, right?
Yeah, and usually when we do our service upgrades, that's the inspector really wants to look at the grounding and bonding of the main service. That's huge for him. He opens up the panel, and usually I'll have the panel open for him to take a look, or her, whoever the inspector is, and they want to see that green ground screw. And sometimes they'll even go up to it with a screwdriver just to make sure it's tight enough, and because again, that's very important to have. And then we'll jump to the other grounding electrodes. So if I actually had one where my guy didn't bond it, and he could tell because the threads were, you know, through 5 or 6 threads facing towards him, and he calls me up, and says, "Hey, you want to get over here and tighten this main bonding jumper down?" And I'm like, "You got a screwdriver on you?"
Yeah.
Because I knew the guy and everything. And actually, he actually did it for me, but he told me to look out next time. Again, I do know some of these guys, but yeah, that's the first thing they look for is that grounding, that main bonding jumper.
Yep.
So.
And so the manner of making these connections for main bonding jumpers or even system bonding jumpers, what we're talking about in a transformer from the XO to the case or to the frame, you have to terminate it in a certain way. So 250.8 gives us a laundry list of acceptable pressure connectors, things like that. That's where you'd see wire binding devices like a wire nut, all these different methods. But you're going to require to make these terminations. Now, this is pretty much, I think, Jay, this is probably taken care of by the manufacturer because they're going to provide the lugs. There's going to be a lug on a bus, and that's a pressure connection. Or they're going to provide a lug at the XO, and you're just simply going to make sure the lug can actually handle the size conductor that you're dealing with, and that you're sizing your system bonding jumper properly, which you're going to see here shortly. And you want to make sure you always are following the manufacturer's instructions. So even these transformers have instructions. Panel boards have instructions. How many people actually read them and understand the torquing requirements? They're on the legend and all that's probably here nor there, but they are there. And I think we get used to just putting those things in and not thinking about it. But when it comes to transformers, because of the nature and the reliability that you need with a transformer, you need to make sure that you're making these connections properly and you're torquing them properly. Okay? Torque everything to the proper specifications for that piece of equipment. All right, sizing.
Every time.
Sizing a main bonding jumper, or in our case tonight, a system bonding jumper. So 250.28A1 is a pretty simple, straightforward way of sizing. And since we're talking about system bonding jumpers, we'll stick with system bonding jumpers. But just reminding you, Jay, that this is exactly how you would do a main bonding jumper. So D1, we're talking about a very simplistic approach. It's just one panel, or it's just one transformer, and it's feeding one secondary conductors are feeding one panel, okay, on the secondary side of a transformer. Very simple, okay? So transformer, panel, okay, is how we're doing it. So system bonding jumper, the requirement is the system bonding jumper, again, in a transformer, that's the connection between the XO, the grounded conductor point, or that we call the neutral point, and the frame, must not be smaller than shown in table 250.102C1. So not smaller. Can it be larger? Absolutely, as long as the lug can handle the size. But it cannot be smaller than what's shown in table 250-102C1. So this is when I tell Jay all the time about grounding and bonding. There's three fundamental tables within grounding and bonding that you got to get familiar with and how you use them. 250.122 is equipment grounding conductors, and they're sized based on the overcurrent device. Boom, easy.
Yes.
Table you go to, no problem. The grounding electrode conductor is sized on 250.66, and that is based on the conductors that are supplying the system. Simple.
Right.
When it comes to grounded conductors, supply side bonding jumpers in general, things like that, you're going to use 250.102C1. And that's going to be either based on the size of the conductors that are supplying the system, where you actually have this main bonding jumper at, or when it comes to a system bonding jumper, it's going to be 250.102C1 based on the derived conductors from the secondary of that transformer. And that's how we're going to size it. Okay, so whatever's leaving, in our case, let's say the transformer secondary, whatever's leaving, let's say going up to a panel with let's say, as a main breaker in there, those are the conductors we're going to use to size the system bonding jumper inside of the transformer. If that's where we're going to choose to have our system bonding jumper. Now, I could have it there, or I could have it at the first panel, either or. And you typically don't have it at both unless you can show there's not a conductive path between the two. And it creates more of a problem. That's an exception allowance. Okay, so typically it's done at one place or the other. And to avoid confusion, you can choose where you'd want to do it. And we'll kind of look at some examples here. But again, we're going to stick with sizing it in the transformer. Okay, just makes it
Yeah,
simple.
I think that's what we've normally done or most of the time is it's done in the transformer itself.
So now the supply conductors from the transformer to the panel, these are the secondary conductors we refer to in many cases. You've heard us say derived conductors. And some people hate the term derived, Jay. I like to think of it this. Yeah. They are theoretically born from the secondary. So they're derived from the secondary. Whereas all of our premise wiring systems are derived from the utility. So I like to say I'm okay with the term derived. But if you want to call them the supply conductors from the secondary, these are all the secondary conductors that are found in 240.21C4, I guess, or whatever, which one it is. I can't remember. C3, whatever it is. So those are the secondary conductors. Having a brain fart on that too. So 250.102C1 supply conductors, if they're larger than 1100 kc mil, because if it's smaller than that, you're just pulling from the table. If they're larger than 1100 kc mil copper or 1750 kc mil aluminum, then we're going to have to do what? The bonding jumper is required to have an area that is not less than 12.5% of the largest phase conductor. Yeah. All right. So let's kind of look and see what we've got here. So as discussed previously, main and system bonding jumpers in listed equipment such as switchboard, panel boards, can be used without the need to calculate the appropriate size of these system bonding jumpers if it comes with the equipment. If it's already in place, if it's already done, then we don't have to do anything. But more often than not, when you got a transformer, you're going to be sizing your system bonding jumper from the XO to the case, right? To the terminal lug case, where you're going to put all your where you're going to have your equipment grounding conductor coming in and in your supply side bonding jumper going out. Okay, all of that's going to be connected together, right? So if it was from the factory, then you don't do anything. And don't get confused on these little straps that are in transformers near the bottom where it's the isolated frame that's on little isolators and it's got a little strap there. That is not the system bonding jumper, okay? That might be some other strap, but what you want to look at, if it's not connected to the XO, and that's not going to the actual lugging system where you would bring in your equipment grounds from the primary side and your supply side bonding jumpers from the secondary side, then that is not the bond. That is not, okay, a system bonding jumper. Okay, so don't think that's what that is. Okay? And it's usually just a thin metal strap, and that is not a system bonding jumper. All right, so now let's look at an example. So I have an ungrounded conductors coming from let's say it's coming from a transformer. And for ungrounded conductors that are 1100 kc mil and smaller, or that's copper, and for ungrounded aluminum that are 1750 and smaller, it's pretty simple. I simply determine the largest circular mill area of the ungrounded conductors. Then I refer to table 250-102C1 for the minimum size of main or system bonding jumper. So this is an example. I have an 800 amp service, or I could have an 800 amp supplied separately derived system transformer that's supplying a panel that's 800 amps of calculated load. That is being installed. And in order to do that, I'm going to run 2 sets of 500 kc mil XADHW conductors, and I'm going to be installing them in parallel. Now, Jay, why do we install things in parallel? So we can get more current out of it, right?
Yeah, more current, and then also you don't have to size one large conductor.
Yeah, one big conductor that's
smaller ones.
Going to affect raceway fill. It's going to affect all those type of things. So in our case, 2 sets of 500 kc mil. Boom. All right. So as it says, you simply take, and here's the other thing that people get lost with. You only take one of the phases. So if it's an ABC, you just take 2 sets, you take the A's, and that's it. So 2 A's would be 500 each. So you do 500 times 2, that's 1,000 kc mil. Well, that 1,000 kc mil is not over 1,100. So I simply just go to table 250-102C1, and you go down and you go over, you find the 1,000 kc mil, and you go over to the right and you're choosing copper. It'd be a 2-aught copper. And that would be the same whether or not it was a main bonding jumper or a system bonding jumper, the same. So if this was a service and it was being supplied by 2 sets of 500 kc mil from your point of attachment down, you're going to do the same thing. You're going to do the 2 500 kc mils, just take one phase, that's it, and add up all the sets for that one leg of the phase, say all A's. In this case, it's just 2 of them. So 500 times 2 is 1,000. And that's how you would size your main bonding jumper if it wasn't a green screw or something that already came in the panel, right? Now, what if they're larger than 1,100 and larger than 1,750 for aluminum? Okay. So you have to determine the total circular mill area of the largest set of conductors. And remember, think only one phase, okay, or one leg in this mentality.
One phase.
So we're thinking, okay. Then you take that, you multiply that by 12.5%. And you remember last night, folks that didn't attend our exam prep last night, we learned how to convert for calculations. And this is a great example. You divide 1 into 2, 0.5. So that's 12.5. So it's 12.5. But we want to convert that to a decimal. So we move 2 spaces to the left. So it's 0.125. So that is our decimal value that helps in our equation. And of course, we're going to be able to have to go to chapter 9, table 8, because we need to look at what the circular mills of the conductor that we're going to calculate out here. And then of course, if it doesn't correspond, then we're going to go up to the next available size. So let's kind of work that out and work all these steps here. So we have a 1,200 amp service, Jay, or it could be a 1,200 amp separately derived system that's feeding a 1,200 amps, panel from the secondary of a transformer. Okay. It doesn't matter. Same thing works either way. So in this case, to get the 1,200 amps, we're going to run 4 350 kc mil copper conductors.
Okay.
So we're going to have 4 raceways. So remember, we're only taking one phase. And so that is 4 times 350 is 1,400 circular mil. So it doesn't take us a lot to look at this and say, well, obviously that's 1,400 is 1,400,000. But to work it out, you would go 1,400 times 1,000, and that's 1,400,000 circular mils. Now, that system bonding jumper or main bonding jumper cannot be less than 12.5%. Okay, so 1,400,000 circular mil times 0.125 equals 175,000 circular mil. So you got to go find a conductor that's at least 175,000 circular mil. And so that takes me to chapter 9, table 8, because that's our conductor properties, remember? And we
Yes.
go down the circular mills and we need to find one that's good for at least 175. It can't be less, can be bigger, but it's got to be able to handle 175. Well, a 3/0's not adequate enough. It's not high enough. So we jump up to a 4/0 because a 4/0 can handle 211,000. And Jay, I don't know what a 3/0 is. I can't remember, but
it's 167,800.
So it's not enough. So we got to go up because we have to at least accommodate that 175,000. So you go to the next size up, and that's a 4/0. And it's good for 211,600, which must be installed if the main bonding jumper by the manufacturer, if they don't have one by the manufacturer and you're having to put one in, or if you're putting in the system bonding jumper for this transformer that's supplying a 1200 amp panel, this is how you would size the system bonding jumper. And the system bonding jumper would be a 4/0 copper in this case. Make sense?
Yeah, no, that makes perfect sense. And I used to get confused on the 12.5%. You would get confused. And actually, to be honest with you, I really never knew about 250-102C1 that often because I'm always so stuck on 250-66 or 250-122. But the way you explained it makes perfect sense. If the largest ungrounded conductors or the equivalent of the areas for the parallel conductors, like you said, the A phases,
keep one
in this
phase
example,
in
you have
mind.
4 of them. You're taking...
Just keep one phase in mind. Don't make it difficult. Forget, if it's A, B, and C phases and you're paralleling 5 sets, then it's 5 A's. Take that and utilize that in scenario. Keep it simple.
You're combining them as if they were one conductor, and then you're sizing your main bonding jumper
or your system bonding
for
jumper.
that, or system bonding for that one size.
So paralleling is basically, even though we have multiple sets, if we're following the rules of 310.10 G or H, depending on which cycle you're in of the code, we're actually trying to create a single conductor with multiple sets by connecting them together at each end and keeping all the characteristics the same so that current divides evenly amongst these conductors. We're basically creating a single conductor, but it's just multiples of these conductors coming together, kind of like a stranded conductor, if you will, right? If helps that analogy. So when you run something in parallel and you connect them at the ends together, they're electrically connected at the ends, they are replicating a single conductor. That's why the characteristics all have to be the same within that set. So all the A's have to be the same conductive material, same insulation type, the same length, those type of things. All that terminated in the same way because they're going to act like a single conductor, but the current's going to divide evenly if you keep them the same length. It's when you start getting varying lengths, then you start having problems because then current won't divide evenly and you could have one conductor that's overloaded and you start to have insulation breakdown and stuff like that. So that's why we have those rules, okay? Now, we'll skip D2 because that's when you're dealing with more than one enclosure because that's what we were kind of making it simple here. But we're talking system bonding jumpers today because we're talking transformers. So we're going to go to the transformer version. And that is 250.28 D3. So this is when you have more than one. And people get confused by this all the time, Jay. They're like, okay, the first one was simple. I get that. What do I do if I've got a transformer and people don't realize that you can supply multiple panels from a single transformer as long as the transformer is adequately sized and you calculate it out right. It can handle the load. Then what happens if I have 2 panels that are being supplied? And one is a 600 amp and one's a 400 amp. And one might have parallel sets to it and the other one might not. But my supply side bonding, the system bonding jumper is going to be in the transformer. How do I size it? And that's where people get confused. So that's what we're going to do right now. So if a system, separately derived system supplies more than one single enclosure, the system bonding jumper for each enclosure is required to be sized in accordance with 250.28 D1. So we've already done that. So if we were putting the system bonding jumper in the panels, if that was our choice, then we're sizing it based on the conductors that are supplying that panel. And that's going to be how we would size for that panel. Okay. So that's straightforward. right?
Yeah, it's simple.
Now,
Simple.
if a single system bonding jumper is installed at the source, which would be, in this case, be the transformer, it must be sized in accordance with 250.28D1 based on the equivalent size of the largest supply conductors. This is determined by the largest sum of the areas of the corresponding conductors of each set. And that sounds like a whole lot of words, right? It's like, okay, what the heck does he mean? Okay. Now, this all kind of came about in the 2008 process to add clarity when it's dealing with more than a single disconnecting means. Now, the system bonding jumper is permitted to be installed at any single point from the source, which would be the transformer, secondary, of the separately derived system to the first system disconnecting means. So you do have choices, right? I can do it in the transformer where we most all do it, or you could do it at the first system disconnecting means, okay? And you can do that because 250.30A1 tells me I can. Now, the system bonding jumper is required to be at the source if it's located outdoors. Okay, so that's something to remember. We talked about where the system. So if I have a transformer that's outside, and that's where the source is, then the system bonding jumper has to be there.
Has
to be out there at the transformer. Yeah. Now that doesn't mean that I don't have one also in the first system disconnecting mean, because there is an allowance under exceptions to allow that to take place. But typically it's done at that single point, okay? All right, so if multiple disconnecting means are installed from a separately derived system, the system bonding jumper must be installed at either the source, that is a single point, that's usually in the transformer, or at the individual enclosures like we just talked about, a single point at each. The single point rule in 250.30A1 would not permit a system bonding jumper to be installed at the source for the supply to one disconnected means and at the disconnecting means for another feeder. Okay, so the 1 point rule, typically, if you go with doing it at the source, that's where you have to stick. You can't have one at the source and then have, say, two panels and have the other one at the first disconnecting means. You have to choose. If you're going to do them at the disconnects, fine. If you're going to do it at the source and the transformer, fine. Okay, not both. Okay, in this case where we have two different panels. Okay, that's called a single point rule. All right, now, if the system bonding jumper is installed in each disconnecting mean enclosure as we're permitted, the size of the derived conductors that connect to the system disconnecting means terminals is used to determine the minimum size of the system bonding jumper in each one. We already kind of covered that, right? We said whatever conductor sizes they're supplying that one, that's how you size the supply side, the system bonding jumper, right? We get it. Yep. All right, now, this was reviewed in discussion 250.28D1. We already looked at that. General, once again, if the disconnecting means is being installed, is listed as service equipment, though in this instance is being used as a feeder panel board and not as a service disconnecting means, the manufacturer will furnish a proper size of system bonding jumper. Usually will come with the actual equipment, the panel board. So we have to be careful. I'm just saying to tell people, be very simple. Do it at the source and leave it less complicated to you, but the manufacturer could supply these. But I'm going to show you what this all means here. If the system bonding jumper is installed at the source, like where it's typically done at the transformer, it must be sized for the total circular area of the derived conductors. So this is where there's a difference. If you were doing each individual and you were doing it at the disconnecting means, then it's based, the system bonding jumper in that panel is all based on the derived conductors. Unless, of course, that panel J had the built-in green screw and you were going to use that and put that in there and do everything there, then that would serve the same purpose. And that's manufacturers, and you don't have to rethink the wheel here. Right?
Right.
But let's say we're doing it at the source like me and you say we like to do, and like most people do, and I think that is what most people will do, is they put it at the source. So let's look at an example. In this figure, I show a separately derived system supplying two feeders. One feeder is to a 400 amp service panel, And the derived conductors are 600 kc mil. And the second feeder is to a 600 amp panel, Jay. And the supply conductors are two 350 kc mil copper conductors that are connected in parallel. A single system bonding jumper is to be installed from the bonding terminal bar installed in the transformer, like we talked about, which is usually along the bottom of the transformer, to the exo terminal in the transformer. So here's what we got right here. So here's the transformer, and this right here is the system bonding jumper. Of course, where the system bonding jumper is also where you're going to have the grounding electrode conductor to the grounding electrode for this transformer. Okay. So then we've got this one feeding this way. So this one over here is the 400 amp device. So this is 600 kc mil. And I noticed that there's a separation here. Okay, separating ground and grounding, grounded and grounding. And then over here, here's where we got the parallel sets. It kind of doesn't show you here, but it gave you this little loopy loop. And we have two 350 kc mil conductors, and this is a 600 amp overcurrent device. So how do you size this system bonding jumper when you do that? Okay, well, let's look at it. The size of the system bonding jumper must comply with 250.28 D1. Okay, so that told us how to size it. That section requires that the system bonding jumper not be smaller than table 250.102 C1, remember? Based on the size of the derived conductors. All right, now, if the derived conductors are larger than 1100 kc mil copper, the system bonding jumper is not permitted to be smaller than 12.5% of the circular mill area of the derived conductors. The following table shows how to calculate the system bonding jumper for the illustration. This one we just looked at right here. So it's pretty straightforward. We have a 600, and we're only going to use one phase because it's just one set, say a black and a red and whatnot. And then this 600 amp is two 350s. So we're going to use one of each set, and we're going to use this phase A, let's say, or line 1 if it's single phase. You can say line 1. All right, so if we have red and blacks, we're just going to use the blacks for both of these sets. So it's 350 and 350, add them together, that's 700 kc mil. So you just add 700 and 600 together, and that's 1300. Well, that exceeds 1100 kc mil copper. So we're going to have to multiply 1,300,000 circular mils times 0.125. And that's going to give us what? 162,500 circular mils. So then we're going to realize, and I think you told me earlier that 3/0 was, what was that, 167.5?
Yeah, it's 167.8
or something like that.
Think. Let me just jump.
Okay, but it does exceed 162.5. So we would go.
It's 167.800. So yeah, that does exceed the 162.5.
Right, so, but what's the one down from that? What is a 2/0?
So a 2/0 is 133.
Okay, so that's not going to work.
100. So 133,100. Yeah,
so
that's way too
So we
low.
had to jump up to 3/0, and we're good because that's 167,800. That can easily handle 162.5. So we used Chapter 9, Table 8, and that's how we sized the system bonding jumper. And it's same, very simple, straightforward on how to do it when you have multiples. And you could have had 3 panels and done the same thing. It would have all been the same. So in here, this right here is why this system bonding jumper is a 3/0. Okay. Makes sense? All right.
Yeah.
Okay, so as I said earlier, one of the powerful things that you need to learn first is what is required to be grounded, what is not required to be grounded, and what is not permitted to actually be grounded. So a good review of 250-20, 250-120, 250-21, and 250-22, as I stated earlier, gives you a good overview of what is required, what systems are required to be grounded. And like I said, traditionally a 122/40 system to a residence is an example of a 250.20 system that is required to be grounded. Okay. In a 3-phase Delta would be an example of one that is permitted but not required to be grounded. That's just kind of some examples there.
And just so you guys know, we're pulling this out of chapter or unit 2 in the grounding and bonding, and this is only like an eighth of unit 2.
Yeah,
and you're already getting into the table. You're already getting into chapter 9, table 8. You're getting into, what's that table? 102.
250, 102C1.
That we were just 250, 102C1 that you guys don't use. So the program itself is going to have you navigate through the code so much that if you just stay the course, you're gonna pick it up. You know, I mean, that was pretty clear what you went through tonight, and that was just a little chunk of it.
Yeah, and it's just a lot of graphics that we have, and again, you can't underestimate the fact that in an hour the time goes pretty darn
it does.
darn quick. But here you see we discuss outside sources. So this discusses what happens when the separately derived system is outside and the grounding electrode connection is required to be made at the source location to one or more grounding electrodes in compliance with 250.50. That's where it tells you the different one, and then it gives you the different options in 250.52 for the different types. So we go into all those and even give you some examples and show you all these illustrations and call outs and everything like that. You also have table of contents where you can always go to and understand the different aspects of it, 250, 32. And so you can kind of jump around anywhere that you want. Equipment bonding jumper, all this kind of stuff, high impedance grounded systems and all that type of stuff. And I realize I'm running out of time for the show. But again, so I guess one of the other things that I probably quickly should talk about, Jay, is when you go from the actual transformer up to the first disconnecting means, okay? And so when we go up to the first disconnecting means, for example, and I'm trying to find an illustration so I can give a visual here. So this is an example of transformer, separately derived system. Here's supplying the primary side, and here's your secondary side. You've got your system bonding jumper in here. This is the location they choose to put it in, as you just saw what we discussed. Here's your grounding electrical conductor down to your electrode that's required and tells you in 250.50, and you select the type of electrode in 250.52. And then going up here to the actual disconnecting means, you have a separation here. Remember, if your system bonding jumper's here, then you're separated up here, separated downstream, if you will. And you'll notice that this is what's called a supply side bonding jumper. Now, this is one being showed of the wire type, but you are allowed to use a fixed metal for the supply side bonding jumper. So it could be an EMT, a rigid, intermediate, anything that's a fixed metal, non-flexible, could qualify as a supply side bonding jumper. But obviously, if you're running this in PVC material or something of that nature, or something that wouldn't be allowed to be used as a supply side bonding jumper, like a FMC or something, you wouldn't be able to use the whole way as a supply side bonding jumper. You might have a small piece of flex that's getting you to your transformer, but then you're going to make sure that you have inside of that a supply side bonding jumper, so you're not relying on that flex. Okay. So, but you could have I've seen people do EMT all the way up, and that would qualify as a supply side bonding jumper. Here we're showing it of the wire type, obviously. And up here you show that they're separated. Okay. And again, this supply side bonding jumper is still going to utilize, Jay, the requirements in 250.102C1. Okay. So if you look at, you guys have that code book. And Jay, I don't know if you have it. If you look at 250.102C1, for all of you that are here real quick, just so I can give you a flavor of that amazing table that came about just a couple cycles ago. If you read it, it tells you 250.102C1, it says right at the top of that table, folks, grounded conductor, main bonding jumpers, system bonding jumpers, and supply side bonding jumpers for alternating current systems. All are sized based on the instructions here in 250.102C1. So if you take anything away from this, And again, it's a big topic. And many of you are probably aware, for those monthly subscribers, I am doing, Jay, did we even talk about this? I am doing 4 episodes of 3 hours each. That's 12 hours of grounding and bonding. And if you're in our monthly membership, you get to come for free. And it is, you get me going through grounding and bonding for 12 hours. So it's 2 times a month for 2 months. Second, what is it? The second and first and third. I can't remember what it is because we haven't released it yet. But as a member of our monthly subscription program, you get access. There's the value right there. It's like $395 series. You're getting it as part of your monthly subscription. So I'm excited to be able to do that, have a sponsor for that that's able to absorb that cost so I can bring it to everybody. So we'll do that.
Yeah, and you already seen what we did within an hour.
How do you cover
and that's,
yeah.
Crazy.
Yeah. So anyway, that's and so if you had to take anything away from the grounding and bondings and things like that, just remember 250.122 equipment grounds are based on the size of the overcurrent device. Grounding electroconductors, like these right here, is all sized based on the conductors that are supplying the system. And of course, your system bonding jumpers and your supply side bonding jumpers, they're going to be based on the derived conductors from the secondary, because they're all going to be driven at 250 to 102 C1. So just things to remember. Grounding and bonding is such a deep topic, and I realize that I'm running way behind on all this, and I gave you literally the 30,000 foot view of it, and I realize in an hour show it's a really difficult, and I apologize if I've lost anybody along the way. It's just tough topic to cover in an hour, right? So, but what we want to do, Jay, is we got to get to real quickly. We'll go to the code turd, get that out of the way. So here's a code turd of the week. Hold on, don't I have a button for that, Jay? Don't I?
Should.
What happened to my...
You got about 100 on your...
Code turd of the week. Okay. So when we look at this, electricians, stop doing this. Now we're going to say this is not an electrician, but it looks like you've got here's your code turd hats on.
Oh my.
We've got, in the middle, we've got 3 non-metallic sheath cables under a staple. I am pretty sure that setup is not designed for 3 cables under there, even though it looks like they all can fit. I'm pretty sure it's not designed for that, but maybe an inspector won't call that out, right? Maybe he won't call that out. But if you look to the left, you'll see that we have a situation where we don't have any non-metallic sheath cable on one of those. Actually, it got to be in the box 1/4 of an inch, and it's not even in there. We've got what it looks like equipment grounding conductors just bundled all together with no device holding them, securing them. So that's where they just maybe just caught the picture at a bad time, right? That type of thing.
Yeah, they weren't done with the installation.
Yeah,
yet.
That's it. They weren't done yet, because they've got what it looks like wire on the right up there that's not even in the box. So this also probably means that we're not going to have at least 6 inches of conductor that's extending into the box as well. So we're not going to have that. So it's just a mess. The whole thing's a mess. The equipment grounds. The other thing I like to tell people, that 6 inches of conductor from the point it emerges from the cable in the box, or from the point it emerges from a raceway in a box, that also applies to the equipment ground, folks. I mean, you know what I'm saying?
Yeah.
It's not just the ungrounded and grounded conductors. Now, granted, the hots and the neutrals, those are the circuit conductors, but the rule also applies to the equipment grounding conductor as well. Okay, so again, you gotta...
Yeah, and that's even if you're cutting off one of, like trimming, let's say you're going into that single gang nail on, and there's 4 NMBs going in there, so you're going to have 4 equipment grounds. Even though you're tying all 4 together and you're only taking one of those, so pretty much you're essentially going to clip the other 3 back. Those other 3 still have to be 6 inches.
Yeah.
You can't just clip them back 3 inches and go, oh yeah, well those ones aren't being connected to the actual device, so I don't need the 6 inches. No, because when I come back and I work on it, I need to have adequate length of wire conductor to work on. If not, I'm going to damage other conductors while I'm trying to get to that ground. So it makes total sense. I'm on my guys all the time about that
I think
stuff.
you had a video out there about. No, it wasn't about that. That was about putting the sheathing into the box, right? Is that what that video was?
Yeah, my guy was he did what they did on the left side. He was about a half an inch above the box. And I was like, "Hey, Brandon, come on over here." And he tried to stretch it up, and he couldn't get it, so he had to run a new cable.
Length of conductor, folks, for those that want their code reference, just 300.14 is what requires you to have 6 inches of free conductor that emerges into that. So the other one that people ask about is the amount of material that has to extend down actually into or get into the actual box, or the 1/4 of an inch. So in that rule is, let's see here.
That's still in 300, isn't it? We're in 300.
Oh, if you the extension down in it. Well,
yeah.
Typically, I mean, what I would see with the box is it comes down into the box. I'm looking for something else because I'm looking for a securing supporting rule that I want to call out on this jack of installations. I should say. So we get
so 314 is the, like you said,
that's a free conductor.
6-inch.
So that's a free conductor and things like that have to extend into the box. So, what else can you see that we should call out on this one?
So in the two gang box to the left where the switch is at, it looks like 2 NMBs are going into one hole, which
I don't have a problem
with. 2 gang or larger,
I don't really have a problem with that. I think that most of those boxes allow for more than one.
Oh, okay.
Yeah, I don't think that I have too much of an issue with that. But your eyes are much better than mine. Okay, when it comes to that. Let's see here. As far as securing and supporting, you know what? I can't really tell. So,
did you go over the sheath one? Did you go over 314.17 B2? That's where it says conductors entering through a cable clamp, and that's where you need a 1/4 inch sheathing in the box.
Okay.
That's 314.17 B2.
Okay, so we got that violation.
Again, I do a lot of NMBs, so
yeah, and I can't see above it, so I don't know. We can't really tell whether it's secured and supported in 334.30 properly or not. So this is kind of a picture is what it is. The other thing that you really can't tell, and we'll point out, is if you actually look on the middle portion, I can't see where that bored hole is, but you want to make sure that bored hole from the edge of the bored hole to the edge of the framing member is at least 1 1/4 inches. Okay, and a 300.4. So and
if not, you want to use a notch plate for it.
Nail plate. You got a nail plate. Throw the nail plate. I think is 1/16 inch nail plates. If you got them, use them. Those type of things. And let's see. I don't. What else is? I don't see anything else. There's just.
I did a drilling video and I posted it on my Instagram, the Basement King 12 on Instagram, and I had a guy tell me, because in my video I was doing a basement and I was drilling at waist level, because again, when I pull my cable, I don't like to bend down too low, and I don't want to get on a ladder to go up high.
You're getting old. You don't want to have to bend over. You're getting old. You're not in spring chicken.
If I'm going vertical, if you're going vertical, obviously you go to the top plate, you're probably going to have to get on a ladder. But I was just going horizontal around the room from box to box. And he goes, a guy on social media said, "Hey, you said every room is like that. What about the big custom homes that, they have cabinetry in their bedrooms and stuff? You'd want to go high." And I'm thinking, dude, if I know that they're going to put cabinetry there, I'm just going to put a notch plate on it, a nail plate. I'm still not going to go high and break my back trying to get something out of the way of the darn cabinet to satisfy them. I'm still going to go waist level with the cable. Yeah. I'm just going to put a nail plate on it, just like I do in kitchens. A lot of times in kitchens, even though I'm 1 1/4 inch back from the face of the stud, I still put a nail plate there because the cabinet guys will use 3-inch screws sometimes, So it's just all situational out there when you're drilling your holes. But there's nothing wrong with throwing them at waist level and putting a notch plate.
No. So again, I think you referenced it, 314.17 think that's B2. Conductors through a cable clamp, and then 1/4 of an inch inside the box, the sheathing. I think you already covered that one. Now,
I covered that.
Stu says you could solve this by moving it up. Yeah, you probably could, but why would you? Why not install it right the first time? Now, where would you may come into an issue? Now, what if this installation on the left side and you moved it up? And now, what if this was a multi-family dwelling and it was under the ADA rules? So informative annex J. And by moving it up, Stu, you moved it outside of the parameters that fall under the ADA compliant. Then that wouldn't be the solution. But I would kind of hope.
Yeah, but even on that one, Stu, that's not going to help you, because if you move it up to accommodate the top NMBs,
the bottom was going to be too short.
The bottom NMBs that come in.
Yeah, that's true.
Either way, this
and
I know Stu's like, you guys are picking on me, man. I'm just messing around, you know. But
Stu, is this your install? I'm just playing. Just playing,
yeah,
Stu.
Stu, is this you? What's going on?
Too personal on this one, Stu. All right.
I know.
All right. Well,
poor guy.
Let's do this. We gotta round this up. So we do have some giveaways. Jay, have you kept track of our giveaways?
Yeah. So we have 2 guys tonight, Demetrio and Aaron.
All right. Now I will remind you folks that won last week that donated. Stuff is in the mail. So gotcha. Already taken care of you. We're thinking of new things that we can do. So, all right. You ready?
So, yep. Let's give it a whirl.
Who we got first? We got Demetrio.
Demetrio is the first
All right, Demetrio.
guy on the list. He beat Aaron on the donating tonight, but you know, I know my brother. He had to come back with it. So Demetrio, you're up.
All right, let's do the spin for Demetrio. Here we go. And we got on the thing. We've got some stickers, a sticker pack, probably like a bunch of stickers. And here you go. And this is just some of them. And then of course we have we got the lights. You're all familiar with the lights. They're magnetic. You can hang them on the panel, cover. Open your panel, put it right there if you want. If you're looking to see what the panel is, you just want to pull it out real quick and see if you're looking to make sure you turn off the right breaker, and boom, boom, boom. There you go. You got that. What else we got, Jay? Oh, we got the screwdrivers. Got a bunch of little screwdrivers here. The metal, they're metal. It's not plastic screwdrivers, by the way. All right, and then of course we've got keychain lights. As you can see, I got some keychain lights to give away, and we have
the green free month
chance to get a free month. Absolutely. And I don't know what that was. It just popped up on the screen, Jay. So I'm not sure.
That was Aaron donating another $19.99.
He will spend twice for Aaron. All right, let's do this. Are you ready?
Yes, times 2.
Dimitri, let's do this. Oh, the excitement. One, an LED light. So there you go. Get the light. All right, Demetrio, what you need to do is you need to send your address to hosts, H-O-S-T, or hosts with an S, H-O-S-T-S, at electricianlive.com. Send us your address, and we'll get that all sent out to you. Again, thank you for the donation. All right. And are you ready? We're going to run, Aaron, your first one here.
Yep, run your first one, Aaron.
There you go. And Aaron, by the way, you are getting a signed book from me. And again, this is probably outdated, and it's a bit old. This is the first book I ever wrote. So it's
cool,
old,
man.
but I have a collection of them because, again, there's only a certain number, and once they're gone, they're gone. But this is actually the first book that I ever wrote. And so I will sign it up and get it out to you, but I'm still waiting for Jay to get me your address so I can get that out to you. So there you go.
Well, you can either send it to
hosts.
I'll email you over.
Aaron, you can also send it to hosts@electricianlive.com as well. Okay. All right, let's do the spin.
Let's spin the wheel for the big guy.
Stickers. So we got a bunch of stickers for you.
Nice.
All right, bunch of stickers.
I love the sticker pack, man. The sticker pack is
Now
cool.
the only problem is, I believe, Aaron, you're not an electrician. So
he doesn't mind.
But what I'll do is I'll make sure the stickers are the ones that are the cool stickers, like the Skull Mafia and the Wizard and those are the cool ones. Okay, so I'll send you some cool ones, and I'll send you the very rare. You ready? The very rare Electrician Live stickers.
That's
very
right.
rare.
Yes.
These are the big ones. Okay, so
all right.
Get
so
you that.
Dimitri got the
LED
the light,
light.
so I got to make this LED light. So hold on before we do Aaron's second one. He has the book just because, again, he's been the top donator for months, and you'll notice his name on that. And so Paul definitely did a big shout out to you, Aaron.
Mm-hmm.
So a signed book by Paul, that's pretty awesome. The sticker pack, and I'll tell you what, if he lands on the free month sub, not only is he going to get a free month sub, but I'm going to throw in this hat right here.
We got a hat giveaway.
Anybody who lands on the free month sub not only gets the free month sub, but they get the hat as well. So tear it up.
All right, ready? Screwdriver. Whoop whoop.
Yay!
These are very handy, Aaron. They, believe it or not, with the 8 bits or whatever's in there, they work. I worked on my glasses the other night with them, but it's all different sizes, and it's all metal, so it's not like a plastic thing. It's going to break when you torque it. It's all metal. So you get that. So you got stickers, and you got screwdrivers. There you go, and you got a signed book. All right.
Look at it. He was on the sliver of almost getting the stickers again, but it just rolled right into that.
Well, if he had got the stickers again,
so
we
awesome.
were going to roll again, because nobody's going to win something twice. The same.
Oh, no one gets it twice. Heck no. Yes, dude. What if you want? Hey, donate $4.99, man. You could get a shot right now.
You know what his
right now at the wheel.
Jay's wife got. Jalissa, you know what she got? She got
get?
some unique Beanie Babies. I have a collection of them. Yeah, I'm a softie. I have some unique Beanie Babies, and I picked out some really neat ones for her. So there you go. Boop, boop, boop. There you go. There's some Beanie Babies. Nobody else wants Beanie Babies. Just the women in the show. Okay. And the kids. Okay. Although I will tell you one that I did send Jay. I am hoping that he names it Zombie, because that's going to be cool, because he's got it and he can have it for the show. Okay. I've got one that I carry for me, the little bear. Most people know that earlier in my career, I did play 1 year of professional golf. And I grew up, all I did was play golf. So I had this all the way back when I became a professional, and played and won my first tournament that I ever played in as a pro, and didn't do squat after that. So it didn't take me but about a year to realize I had to feed the family. So that I ended that career. But at any rate, I keep him near because he's the PGA one. There you go. So anyway, if you're into those things. All right, guys, great show tonight, folks. We appreciate everybody that's joins us. Hopefully you got something out of it. Again, if I didn't go as deep as you wanted, I apologize. Again, I can only cover what I feel is the most important part of grounding and bonding with transformers, is understanding supply side bonding jumpers, and how to size them. And again, that's pretty straightforward, so we didn't go too deep into that. But system bonding jumpers can be confusing when it comes to being inside of a transformer. So if you really want to be in the grounding and bonding, the 2 month, I guess it's 4 3-hour sessions, then you're going to need to go over and subscribe to our program. It's $9.99 a month or $119 a year. And you get access to all the videos that we're doing, even the one on residential wiring that me and Jay are working on. If you haven't been there before, if you are a member, there's like, what is it, Jay? There's like 11 or 12 episodes already up there with the residential wiring. It's already up there. So go check it out. There's an extensive series on swimming pools that me and Vince Delacroce did. Okay. And so that's up there. And
Yep.
what else is let's see here. What other videos are there? Tons of exam prep. Also, all of our stuff that we do for the fast tracks. Hopefully you've been enjoying that on Wednesday night, kind of sitting in on our fast track sessions. But if you want to get in on it and you're trying to study for an exam, there is no better program than the fast tracks. Check that out over on the website as well. Use the links that Basement Kings got for you there. And you can find out all the stuff you want about the programs. Okay. So, but yeah, if you want to get into that, it's starting in November, and it's running November and December, when we're going to have that special grounding and bonding, and we're going to go through a lot of stuff, and it's all going to be based on our grounding and bonding program. And if you really feel like you're weak in grounding and bonding, then it is one of the better. It's a lot of reading, don't get me wrong, but I'm always here as you go through the program and you have questions. I love talking grounding and bonding. I do struggle with how to do it in an hour because I am so long-winded anyway, as you can tell. But I'm always here to help answer the questions, okay? And again, we do the best we can in trying to get that answer for you and do it in a way that you can understand it so it's not overly complicated. A lot of people teach grounding and bonding and they want to throw terms out there and try to confuse you and impress themselves. I'm not here to impress myself. I'm here to teach you if I can teach you something. So with that said, I believe that's... is that it, Jay? Are we done for this week's session?
Yeah, I think that's and then next week I think we're gonna end up. Are we just gonna rebroadcast?
I don't know if we're going to rebroadcast or we're going to record one maybe for Friday for release of next week, but it won't be live because I'm going to be out of town, and I would do it live where I'm at on vacation, except for the Wi-Fi and all that kind of stuff sucks, and it would never be able to handle the stream. It would never handle it. It barely can handle the email. So at the end of the day, that's what it's all about, right? Vacation, you got to get disconnected away from things.
Yeah, you have to disconnect sometimes.
There you go. So let's go on and empty that tip jar. We thank everybody for the tips, and we're going to empty it. Boom. It's gone. Thank you all for that. Just like that. It's gone. Just like that. Just like the next time you get paid, your paycheck. It's gone. Just like that. All right, guys. Till next time. Stay safe. God bless.
You're listening to Electrician Live with your host, Paul Abernathy and Jay Grundberg.